Hey there guys, in this episode we are walking through the Edexcel June 2018 Higher GCSE Maths Paper 1. So I can remember very well the reaction to this paper was definitely not a positive one. So hopefully you're going to find this video helpful. I'll put useful links to topic playlists down below in the description, as well as my formula video and other useful bits and bobs. So let's get cracking. Okay, question 1 wants us to work out 2 and 1/7 add 1 and 1/4. So both of these are a mixed number. I'm going to show you a cheeky little trick here for when we are adding mixed numbers. So 2 and 1/7 we can think of as 2 add 1/7, and then we got add 1 1/4, which we can think of as 1 add 1/4. So we can reorder this to 2 plus 1 add 1/7 add 1/4. 2 plus 1 on a good day is 3. And then to add these fractions, really we'd want to go for common denominators. So the first number that 7 and 4 both go into is 28. So to turn 1/7 into 28, we multiply the top and bottom by 4. So we got add 4 28. And then to turn 1/4 into 28, we're going to multiply the top and bottom by 7. So then we get add 7 28. So altogether we've got 3 and 11 28. Part B wants us to work out 1 and 1/5 divided by 3/4. We want to give our answer as a mixed number in its simplest form. So the first thing we need to do here is convert the mixed number into an improper fraction. So 1 and 1/5, well, you multiply the whole number by the bottom of the fraction. So 5 times 1, and then add the top of the fraction. So that's going to give us 6/5 divided by 3/4. Now, to divide by a fraction, you flip it over and multiply by it. So this is 6/5 times 4/3. So then when we multiply fractions, we do the top times the top over the bottom times the bottom. So 6 times 4 is 24. 5 times 3 on the bottom is 15. Now this has a common factor of 3, so we can simplify it to 8 over 5. Now we want to turn that into a mixed number. So we think, what is the biggest number underneath 8 that 5 goes into, which is 5. So we can say this is 5/5 add 3/5, which is 1 and 3/5. Question 2. In a village, the number of houses to the number of flats are in the ratio 7:4. Straight away, I'm going to write that H2F 7 to 4, and the number of flats to the number of bungalows are in the ratio 8 to 5. Okay, we are told there are 50 bungalows in the village. We want to work out how many houses are in the village. So what we're going to need to do here is combine these two ratios. First of all, I've got a video on that, or a video or two. I'll put them down below in the description. So the key to combining ratio is the part that turns up in both ratios here. So here, that's flats. Now what we want to do is turn this common part of each ratio into the same number. So we can quite easily turn 4 into 8. So we're going to multiply the left-hand ratio by 2. So that's going to give us 14 to 8. So now we know if there are, or for every 8 flats, there are 14 houses, and for every 8 flats, there are 5 bungalows. So we can now write this as a single ratio, houses to flats to bungalows is 14 to 8 to 5. Okay, so now we can use the fact that there are 50 bungalows to work out how many houses there are. So there are 50 bungalows. So what we think now, what we ask ourselves, is how do we turn 5 into 50? We multiply by 10. So we're going to do that to the other parts of the ratio. So we don't need to do it with flats, I'm just kidding. So 8 times 10 tells us there are 80 flats. 14 times 10 tells us there are 140 houses. So our answer is 140. Question 3. Renee buys 5 kilograms of sweets to sell. She pays £10 for the sweets. She puts all the sweets into bags. She puts 250 grams in each bag. She sells each bag for 65p. Renee sells all the bags of sweets. We want to work out her percentage profit. So to be able to do that, we're going to need to work out her profit. To be able to do that, we're going to need to work out how much she makes in total by selling the sweets. To be able to do that, we're going to need to work out how many bags of sweets she sells. So, she's got 5 kilograms of sweets. Every 1 kilogram is 4 times 250 grams. So every 1 kilogram is 4 bags. So 5 kilograms is going to be 20 bags. So now we know how many bags she sells, we can work out how much she makes. So we want to do 20 times 65p. So to do this, I'm going to first of all do 10 times, I'm going to write it in terms of pounds, 0.65. Now that's going to give me £6.50. So up to there I've multiplied 65p by 10. In total I want to multiply by 20. So I'm now going to do 2 times £6.50. And that is going to give me £13. So when she sells all her sweets, she makes £13. So now we can work out our profit. So profit is the money that you make minus the money that you had to spend. So here, £13 minus £10, that's going to give us £3. So that is the actual profit. Now, percentage profit is well, we want to know what percentage is this £3 of the total amount she had to spend. So we do 3 divided by 10 times 100, and that gives us 30%. Question 4. A cycle race across America is 3,069.25 miles in length. One knows his average speed for his previous races is 15.12 miles per hour. For the next race across America, he will cycle for 8 hours per day. We want to estimate how many days one will need to complete this race. So, with estimation, we're going to make these numbers a lot nicer. So, we're first of all going to say total distance is 3,000 miles, and we're going to say his average speed is 15 miles per hour. Okay, so now we can work out his distance per day. So his distance per day, roughly using our estimation, if he's going to cycle 8 hours per day and he goes at 15 miles per hour, then we want to do 8 times 15. So 8 times 10 is 80, 8 times 5 is 40, so that's going to give us a rough estimate of 120 miles per day. So now to work out the number of days, we do the total distance, so 3,000 divided by 120. So the total distance divided by the distance he goes per day. So both of these fractions end with a 0. So we can say this is 300 divided by 12. we might then spot there's a common factor of 6 between the top and the bottom. So this is 50 divided by 2, which gives us 25. Okay, then part B, 1 trains for the race. The average speed he can cycle increases. It is now 16.27 miles per hour. How does this affect our answer to part A? Well, if he's going a faster average speed, it's gonna increase the distance that he goes every day, so it's gonna take him less days to complete the race. So we can say it will take less days to complete. Cool. Question 5. So here we got a solid square-based pyramid V, A, B, C, D. We're told the height of the pyramid is 4 centimeters. The base of the pyramid is a square of side length 6 centimeters. We are told M is the midpoint of BC and M to V is 5 centimeters. So that's telling us basically the height of one of these triangles. It's the slant height though, not the perpendicular height of the pyramid. That is 4. So our first mission is to draw a front elevation from the direction shown. So the base is 6 centimeters long, the height is 4 centimeters. So what we get is something that looks like that. Cool. Okay, then part B wants us to work out the total surface area of the pyramid. So that means the area of every face added together. So let's start with the base, which is a square. So the square has sides 6 centimeters. So the area of the square is 6 times 6, which is 36 centimeters squared. Okay, now the other type of face we're going to have is a triangle. And there's 4 of these. Now we know the base is 6 centimeters. Now the height of each triangle, this is where this other dimension comes in handy now, is going to be 5. So the height is 5 centimeters. So the area of one triangle is, well, remember, area of a triangle is 1/2 base times height. So it's 1/2 times 6 times 5, which gives us 15 centimeters squared. So the total surface area is the square. So 36, add 4 of the triangles, 4 times 15 centimeters squared. So that's 36, add 60, which gives us 90. Doesn't at all. gives us 96 centimetres squared. Question 6. So this was one that everybody hated. They went a bit mad on Twitter about this question. So a pattern is made using 4 identical squares. The sides of the squares are parallel to the axes. Now we got this point A down here with coordinates 6, 7. Point B is up here with coordinates 38, 36. Point C is here in the middle, and we want to find the coordinates of point C. So, first thing to note, point A is the bottom left corner of one of these squares. Point B is the top right corner of one of these squares. Point C is a bit awkward because it's not on a point of both of these squares. Yes, it is on the bottom left of one of these squares, but then with the square on the left, it's sort of down the side a little bit. So, it's 5 marks. How are we going to do it? Questions like this are all about processing the information that we've got. We've got 4 identical squares here. What do we know about squares? Their side lengths are the same. Now if we look at how these squares are joined, going from left to right, they are all attached so that there is no overlap between any of the squares. So if we call the side length of the square L, then we're going to think, how do we get from this x coordinate of 6 up to this x coordinate of 38. So, well, there's 4 squares between these points. So we go along 4 lengths of the square. So what we could say is that 6 add 4 of the side lengths, so add 4L is equal to 38. Now we got an equation in terms of the side length of the square that we can now solve to find that length. So if we take away 6, we get 4L is 32. Divide by 4, L is 8. So now all of a sudden we know the side length of the square. So what we can do now is, well, we can work out the coordinates of C. So we're now thinking, how do we get from the x coordinate of A to the x coordinate of C? Well, we add 8 here, and then we add 8 here. So the x coordinate of C is 6 add 16, which is going to give us 22. So we got the x coordinate, now we need to get the y coordinate. Now we can't go up from A because point C isn't on the corner of that second square. So what we're going to do is go down from point B. So we're going from 36 and we're minusing 8 there, and we're minusing 8 there. So the y coordinate of C is 36 minus 16, which is equal to 20. So the coordinates of C are 22, 20. Good times. Question 7. So we got this triangle here, which is called shape T. We're told shape T is reflected in the line x equals minus 1 to give shape R, and then shape R is reflected in the line y equals minus 2 to give shape S. We are asked to describe the single transformation that maps T onto S. So it's only 2 marks, which is a bit tight. First thing I've done here is put in those reflection lines. So the red line here is x equals minus 1, and the purple line is y equals minus 2. So we're going to carry out these these two reflections first of all, and see what we end up with. So if we're reflecting T in the red line, let's start with this point here. Count how many places left we have to go to the red line, which is 2. So it gets reflected 2 squares to the left of the red line. The tip of the triangle is 3 places to the right, so it's going to reflect to 3 places to the left. And then this final point is 4 places to the right, so it's going to reflect 4 places on the left. So use a ruler on the real thing. And there is our shape R. So that now reflects down through the purple line. So if we start with the bottom left point of R, that is 3 places above. So it's going to reflect to 3 places below, directly below. So that's going to be here, and then the bottom right point is just 2 places to the right, there, and then the tip of the triangle is going to be in there. Okay, so if we then draw the triangle in, that is now shape S. So what we now need to do is describe how we get from T to X. Okay, so it's flipped over, it's completely upside down, so we would want to say it's a rotation of 180 degrees. Now the trickiest part is that we also need to say where the centre of rotation is. So when you reflect through a vertical line and then a horizontal line, it's always a rotation, and the centre of that rotation is where the lines meet. So our centre of rotation here is -1, -2. So we then need to say centre -1, minus 2. Good times. So that's the answer that I would go for. I think that's the easiest one to see. You could also describe it as an enlargement. So every point here is the same distance to the right and above this point here where the lines meet, as the points down here are to the left and below it. So we could call this, or we could say it's an enlargement through minus 1, minus 2, with a scale factor of minus 1. So a negative scale factor moves your shape through the centre and to the other side. Here our shape is exactly the same size, so the scale factor is just minus 1. So either one of those is absolutely fine. Personally, I'd go for the rotation. I think it's easier to see. Question 8. The perimeter of a right angled triangle is 72 centimetres. The lengths of the sides of the triangle are in the ratio 3 to 4 to 5. We want to work out the area of the triangle. Okay, so this ratio of the side lengths is the ratio in its simplest form. If we had a triangle with side lengths of 3, 4, and 5, the perimeter would be 12, which isn't big enough. So we want the perimeter to be 72. So we want to work out what we need to enlarge this shape by, what scale factor, to get a perimeter of 72. Now, 72 divided by 12 then is 6. So we actually want to multiply these side lengths by 6. So we would get 18. Nice to see my drawing is awesome, as always. 24. And 30 for the hypotenuse. So let's just check that. 30 add 24 is 54, add 10 is 64, add 8 is 72, as we wanted it to. So this is our triangle. The area then is 1/2 times 24 times 18. Now that doesn't look like the nicest thing to work out with our calculator. What I would do here is think of it instead as 1/2 times 18 times 24. Now 1/2 times 18 is 9. So this is the same as 9 times 24. Now 10 times 24 is 240. So we then want to take 24 off of that, and we get 216 centimetres squared. 9a wants us to write down the value of 36 to the power of 1/2. So that means the square root of 36. Technically when you square root a number, you get a positive and a negative answer, However, when we're dealing with indices like this, we really only seem to worry about the positive answer. So it would just be 6. If that was a 2 marker, here it's just 1, then we would write plus or minus 6. Part B wants us to write down the value of 23 to the power of 0. Any number to the power of 0 is 1, except for 0 itself. Doesn't work for 0, but any other number, the answer is 1. Then we want to work out the value of 27 to the minus 2/3. Okay, so the negative part of a power takes our number and the rest of the power down onto the bottom of a fraction with a 1 on top. So the first thing we can do is write this as 1 over 27 to the 2/3. Now when we have fractional powers like this, we're going to split the power up. So we're going to say this is 1 over 27 to the 3rd squared. So that is now 1 over, or 27 to the 1/3 is asking for the cube root of 27, which is 3. So we got 1 over 3 squared, which finally gives us 1 over 9. I'll put a link to my indices playlist down below in the description, where there's loads of examples of different types of problem. Okay, question 10. So the table shows information about the heights of 80 girls. So we got the least height, greatest height, lower quartile, upper quartile, and the median. They want us to draw a box plot to represent this information. So, in box plot, it will look something like this. So, let me walk you through it. The first vertical line on the left is the least height. Then the next vertical line is the lower quartile. The next is the median. The next is the upper quartile. So you draw a box connecting the lower and upper quartiles, and then that final vertical line on the right is the greatest height. So we get 3 marks for that. That's quite nice. Part B wants us to work out an estimate on the number of girls with a height between 133 and 157 centimeters. So 133 is the shortest or the least height. 157 is the upper quartile. So between the lower quartile and the upper quartile, we have the middle 50%. So from the least height up to the upper quartile, so we're going to say from least height to upper quartile, we would expect, so I'm going to say we would have roughly 75% of the girls. So we want to find 75% or 3/4 of 80. So let's do the fractions. 3/4 of 80. Well, 1/4 is 20, so 3/4 is 60. So 60 is our guy. Okay, question 11, we got a lovely 5 marker here. So, A and B are points on a circle, centre O. B, C, so the bottom line is a tangent to the circle. A, O, C is a straight line, so that diagonal line on top, if you like, is a straight line. Angle ABO is X degrees. So straight away, that's going to be important, so I'm going to draw that on. Angle ABO is the angle you get when you go from A to B to O. So, if I draw this line here, we know this angle is X degrees. Okay, now we want to find the size of angle ACB. So that is this angle over here. Question mark on it. We want to give our answer in its simplest form and in terms of X. So we're not looking for a number. And we want to give a reason for each step of our workings. So it's a 5 marker, so we're going to have to do quite a bit here. Okay, so let's zoom in here. What do we know here? Well, we know O is the centre of the circle. So this blue line that I've drawn here is a radius, and the line AO is a radius. So we know this angle, that side length and this side length are equal. So what we can say here is AOB is isosceles. So we can say that angle OAB is X degrees. So what we're saying here is because this triangle is isosceles, this angle is also X degrees. So that will be my first step. The next step relies on a little bit of circle theorem knowledge. So again, this blue line here is a radius. This line at the bottom, BC, is a tangent. So the circle theorem that we need is that a radius and tangent meet at 90 degrees. So they are perpendicular. So that means this angle here is 90 degrees. So I'm going to make a little sketch of this triangle now. So as always, pretty bad sketch. Never mind. So we know this angle up here is X. Now we know this whole angle down at the bottom is X is part of it on the left, and then we got the right angle bar of it on the right. So this angle in total is x plus 90. Now, what I'm going to do is I'm going to call the angle that we want angle y. So, now we know angles in a triangle sum to 180. So, what we can say is y add x add x add 90 is equal to 180. So now we need to take everything over on the right hand side. Let's simplify the left, I suppose, first of all. So we got y plus 2x plus 90 is 180. If we take away the 90, we get y plus 2x is equal to 90. And then finally, minus the 2x, y, the angle that we want, is 90 minus 2x. So that is our answer, 90 minus 2x. Question 12, we got some nice algebraic proof. So we want to prove that the square of an odd number is always one more than a multiple of 4. So, never ever with questions like this, just put numbers in, so don't go like 3 squared is 9, oh, that's 1 more than 8, so it's 1 more than a multiple of 4, good times. What we need to do first of all is work out what to call odd numbers. So we're going to call an odd number is, well, if n is a whole number, then we know 2n is even, so if we add 1 to it, 2n add 1 is always odd. So, if we now square that, so 2n add 1 squared, well that means 2n plus 1 times 2n plus 1. So, use whatever method you're happy with for this. I would always recommend the table. So we're going to put 2n and 1 across the top, 2n and 1 down the side. The 4 empty boxes are now a multiplication between what's above and what's at the side. So 2n times 2n is 4n squared, 2n times 1 is 2n, and then we got this 1. So we can now say then 2n plus 1 squared, our odd number squared, is 4n squared plus 4n plus 1. Now, notice here, the first two terms have a common factor of 4. So we could write this as 4 lots of n squared plus n plus 1. Now, 4 lots of n squared plus n is a multiple of 4. We are then adding 1 to it. So whatever 4 lots of n squared plus n is, that's a multiple of 4. We are then adding 1 onto it. So we're always going to get 1 more than a multiple of 4. I guess what you would want to say here is, let's just do it down here. So you would really want to write something like 4 lots of n squared plus n is a multiple of 4. So 4 lots of n squared plus n plus 1 is 1 more than a multiple of 4. With proof questions, it is important to say why what you've shown shows what we were asked to prove. Question 13, we got some Surd fun, so I'm definitely sticking my Surds playlist down below in the description. All sorts of videos in that. It's a good time. Check it out. So, here we are told that root 5 times a root 8 and root 18 can be written in the form a root 10, where a is an integer. Our job is to find the value of a. So before we think about expanding the brackets, we are going to simplify what is inside the brackets. So, root 8 can be written as root 4 root 2. Now the square root of 4 is 2, so this is 2 root 2. Root 18 can be written as root 9 root 2, which is 3 root 2. So, inside the brackets, root 8 add root 18 is 2 root 2, add 3 root 2, which is 5 root 2. So, that's what we've got inside the brackets. So now we're doing the whole thing root 5 times root 8 add root 18 is root 5 times 5 root 2. So we can write that as 5 root 2 root 5, which we can then combine root 2 root 5 to give us root 10. So it's 5 root 10, so A is 5. Question 14, we got another lovely 5 marker, and it's all about proportion. So I'll put my proportion stuff down below in the description. So y is inversely proportional to d squared. When d is 10, y is 4. D is directly proportional to x squared. When x is 2, d is 24. We want to find a formula for y in terms of x, giving our answer in its simplest form. So that means we want y equals something to do with x. So we're going to deal with each proportion separately first of all. So the top one, y is inversely proportional to d squared. So from that we get that y is proportional to 1 over d squared, and the formula that we would use, so I'm going to do that down here, is y is equal to k over d squared. So now we use the initial conditions that we're given, those values that we're told about y and d, to find the value of k. So when d is 10, y is 4. So we get 4 is equal to k over 10 squared, which is 100. So that tells us k is equal to 400. So what that gives us is the exact formula linking y and d squared. So we can now say y is 400 divided by d squared. Okay, now we'll have a look at the second proportion. So d is directly proportional to x squared. So in proportion notation, we can write d is proportional to x squared. Now the formula that we use there is d is equal to kx squared. So again now, we need to track down the value of k. So we sum in the values that we're told. So when x is 2, d is 24. So we know then 24 is equal to k times 2 squared. So k times 4, 4k. So if we then divide both sides by 4, we get k is 6. So we now know the formula linking d and k squared. So we now know d is equal to 6x squared. So what we're going to do now, we're going to use this formula in the one that we worked out for y and d squared. So y is 400 over d squared. Remember, we want y in terms of x. So we're going to substitute our expression for d into our expression for y. So y is 400 over d squared, which is 6x all squared. Sorry, 6x squared all squared. So we got 400 over 6x squared. Now, when we square that bracket on the bottom, we get 36x to the power 4. Now there's one last thing to do here. There's a common factor of 4 between the top and the bottom. So we're going to divide that away, which gives us 100 over 9x to the power 4. So that's our answer. Y in terms of x is 100 over 9x to the power 4. Good times, quite a tricky one. Okay, 15a wants us to factorise a squared minus b squared. So this thing is called the difference of two squares. It's a special type of quadratic if it was in terms of x. So this factorises to a plus b times a minus b. Cool. Okay, then part b says hence or otherwise simplify fully x squared plus 4 all squared minus x squared minus 2 all squared. So we could expand these brackets and then simplify the terms like that. That's going to be a long way around though. So when questions say hence, it means something that we've done above will help us here. So if we go back up and take a look at a squared minus b squared, then we've got one thing being squared minus another thing being squared. So that is exactly the situation that we have here. So if we say x squared plus 4 squared is our a squared, then we got minus x squared minus 2 all squared, so that's minus b squared. So we've just said that to factorise this, we would do a plus b times a minus b. So if x squared plus 4 all squared is a squared, then a is x squared plus 4 and b, well, if b squared is x squared minus 2 all squared, then b is x squared minus 2. So a plus b is x squared plus 4, so that's a plus x squared minus 2, so that's our a plus b. And then in our second bracket we want a minus b, so we want x squared plus 4 minus x squared minus 2. Okay, so if we now simplify that, in the first bracket we've got x squared plus x squared, so that's 2x squared. We got plus 4 minus 2. So in this first bracket we got 2x squared plus 2. Now in this second bracket, be really careful here because we got this minus. So we got x squared, and now this second x squared is going to be a negative x squared because there is a negative outside the bracket. So the x squared terms here cancel out. And then we got 4 minus minus 2. So 4 minus minus 2 is 4 plus 2, which gives us 6. So now both things in the first bracket are being multiplied by 6. So this is going to give us 12x squared plus 12, which is a perfectly fine answer. Good times. Question 16 tells us there are only red, blue and purple counters in a bag. The ratio of red to blue counters is 3 to 17. So straight away we're going to write that down. Red to blue is 3 to 17. Sam takes a random counter from the bag. The probability he gets a purple is 0.2. We want to work out the probability that he gets a red. So this is probably quite a tricky one again. I know you guys don't like ratio. So I think the easiest way for us to go here would be to work with percentages. So to change a decimal into a percentage, we multiply by 100. So we can say then the probability of getting a purple, well, it's 0.2. If we multiply that by 100, then we get 20%. So that tells us 80% of the counters are red or blue. So what we're going to do is split 80% in the ratio 3 to 17. So we want to split 80% in the ratio red to blue 3 to 17. So first step, add the parts of the ratio together. 3 add 17 is 20. Work out how many lots of that there are in 80. So 80 divided by 20 is 4, and then multiply each side of the ratio by that number. So 4 times 3 gives us 12%. That's what we're after. 4 times 17, it would give us 68%. We're not interested in that though. We are interested in the 12%. So you could write that as a decimal, 0.12. You could even write it as a fraction, because they are all the same stuff, but we might as well just leave it as a percentage. 17 wants us to simplify fully. 3x squared minus 8x minus 3 over 2x squared minus 6x. So to simplify algebraic fractions, the first thing you want to do is factorise the top and the bottom where possible. So we're going to do the top and bottom separately. So starting with the top, 3x squared minus 8x minus 3. So this is certainly a harder quadratic because we have a number attached to the x squared term at the start. So I got a really nice method to factorise these guys. I'm going to put a link down below to my video with far more examples on it. So the first step is to multiply the coefficient of the x squared term by the number at the end. So 3 times minus 3 is minus 9. Now, we now need to think of two numbers that multiply together to give us minus 9 and add together to give us minus 8. So we want them to times together to give us minus 9 and add together to give us minus 8. So two numbers that will do that, it would be a 1 and minus 9. So they are the only two numbers that will do that. 1 times minus 9 is minus 9. 1 and minus 9 is minus 8. So then we go back to our quadratic and we need to check out how many x squareds there are. So there are 3 x squareds. Now we open two sets of brackets, and each one, because we have 3x squared, each bracket has 3x inside. Okay, now each of our two numbers goes inside one of the brackets. So we can have 3x plus 1 times 3x minus 9. Now there's one final step in at least one of the brackets. There will be a common factor. So the last step is to divide away that common factor. So there isn't one in the first bracket, 3x plus 1, but there is in the second bracket a common factor of 3. So we just divide that away and we get x minus 3. So there is the top of the fraction factorised. Now we want to factorise the bottom, 2x squared minus 6x. So a little bit easier, hopefully. First of all, there's a common factor of 2. So we can write this as 2 lots of x squared minus 3x. And then there's still a common factor inside the bracket of x. So we're going to bring that factor out the front as well. So at the front we got 2x. And then divide x squared minus 3x by x, and we get x minus 3. So the fraction is now 3x plus 1 times x minus 3 all over 2x times x minus 3. Now the whole point of factorising the top and the bottom is to see if there are common factors. So here there's a common factor of x minus 3 top and bottom. So they cancel each other out, which leaves us with 3x plus 1 all over 2x. Nothing else we can do there. That's a fine answer. Number 18, we have a sketch of y equals sine of x for x between minus 180 and positive 180. So there's our sketch. We are asked on the grid to sketch the graph of y equals sine x minus 2 for x between minus 180 and positive 180. So the way that we are transforming this function, we're going from f of x equals sine of x to sine of x minus 2. So the minus 2 is not directly involved in the sine function. So this is of the form f of x minus 2. Now what this does, it's a translation by 0 minus 2. So what that means in English is the graph moves down by 2. So every point is going to be 2 places below where it is now. So starting from the left, at this point the minus 180, 0 will now be a minus 180, minus 2. The trough at minus 90, minus 1 is now going to be a minus 90, minus 3. The point that went through 0, 0 is now going to be a 0, minus 2. The peak at 90, 1 is now going to be a 90, minus 1. So that's going to be there. And then this final point at 180, 0 is now going to be a 180, minus 2. So now we just need to join these points up, which I'm sure, because I can't draw, it's going to go disastrously. Okay, so we should get something that looks like that. So that comes under transformations of graphs. I'll put a link to my video on that down below in the description. Okay, now we got 2 big 5 markers to finish off on. Lovely. So question 19 says that point P has coordinates 3, 4, point Q has coordinates A, B. A line perpendicular to PQ is given by the equation 3x at 2y is equal to 7. We want to find an expression for B in terms of A. So this might seem like a complete what the hell is this on about question. So when 2 lines are perpendicular, their gradients multiply together to minus 1. So if we find the gradient of this line whose equation we know, we would then be able to find the gradient of the line PQ. And then from that, we're going to see how we can find an expression for B in terms of A. What that means is we want to get B is equal to some stuff to do with A. So, first thing I'm going to say that I'm going to call this second line, let's call this line L. So, because L and PQ are perpendicular, the gradients, so the gradient of L times the gradient of PQ, because these lines are perpendicular, their gradients multiply together to give us minus 1. So our first job is going to be to find the gradient of line L. Now to do that, let's just remind ourselves up here, we always need a line in the form y equals mx plus c. So m is the gradient. So we first of all need to rearrange 3x add 2y equals 7 to get y on its own. So let's do that. So 3x add 2y is equal to 7. If we first of all take away 3x, 2y is minus 3x add 7. And then if we divide by 2, we get y is equal to, well, we could write this as minus 3x plus 7 all over 2. We could also divide the terms separately by 2, which is what I'm going to do here. So we get minus 3 over 2x add 7 over 2. So from that, we now know the gradient of line L is minus 3 over 2. So using the formula up above, gradient of L times the gradient of PQ is equal to minus 1. Well, we now know. So minus 3 halves times the gradient of PQ is equal to minus 1. So the gradient of PQ is equal to minus 1 divided by minus 3 over 2. Now, when you do a negative divided by a negative, that's going to give us a positive. So the negatives cancel out. So this is exactly the same as 1 divided by 3 halves. Now when we divide by a fraction, you flip it over and multiply by it. So this is 1 times 2 thirds, which gives us 2 thirds. Okay, so what we know up to here is we know numerically the gradient of PQ is 2 thirds. Okay, so that's quite a nice point to get to. Now remember, we know the coordinates of P and Q. So P has coordinates 3, 4, and Q has coordinates A, B. So what we can also do is work out the gradient in terms of the coordinates. So P is 3, 4, Q is A, B. So remember, gradient, so M, again, gradient is in my straight line playlist, which is down below in the description. So gradient is the difference in y, so I call that dy, divided by the difference in x. So up on top we could say b minus 4, so the difference in the y coordinates. Now because I've done b minus 4 on top, on the bottom I have to do a minus 3. So we also know then the gradient of PQ is b minus 4 over a minus 3. So that's an expression for the gradient in terms of b and a. We actually know the gradient is 2 thirds. So what we can now do is set these two things equal to each other. So we can say b minus 4 over a minus 3 is equal to 2/3. Now we want to get b on its own. So we can multiply through by a minus 3. That's all one number. So we can get b minus 4 is 2 lots of a minus 3 divided by 3. And then to get b on its own, we're going to add 4. So that's going to give us b is equal to 4, add 2 lots of a minus 3, which we can, if you want, expand. So 2a minus 6 all over 3. Now that is exactly right. So I think if you stop there, you'd be fine. They haven't asked for it in any particular form, but it's not in the form the mark scheme has it. So just to prove to you that this is right, we can split this fraction. So we could say we got 4 add 2/3 a minus 6 over 3. Now, this is equal to 4 add 2/3 a minus 2, which we could write as 2/3 a add 2. So that's how they have it in the mark scheme, but you'd be happy as Larry stopping there. So if that isn't a level 9 question, then I don't know what is. Pretty tricky stuff. Hope you followed it alright. One more to go. Okay, question 20. So n is an integer, so a whole number, such that 3n plus 2 is less than or equal to 14, and 6n over n squared plus 5 is greater than 1. We want to find all the possible values of n. So basically solve each of these inequalities and see what values that allows us for n. So the first one is a linear inequality. He should be alright. The second one though is a quadratic inequality, so maybe a little bit tricky. We're going to start off with that guy. And also my inequalities and quadratic inequalities playlists will be down below in the description. So let's start off then with 6n over n squared plus 5 is greater than 1. Okay, so we don't want n squared plus 5 on the bottom of the fraction. So first thing we need to do is multiply both sides by n squared plus 5. So that's going to give us 6n is greater than 1 times n squared plus 5. So that is going to give us n squared plus 5 over on the right. So it's a quadratic, so just like when we're solving equations, we want everything on the same side together with a 0 on the other. So we're going to subtract that 6n, and that's going to give us 0 is greater than n squared minus 6n plus 5. So I don't like it written that way around, so I'm going to rewrite that as n squared minus 6n plus 5 is less than 0. So now we have a quadratic inequality that we need to solve. So the first thing to do is think of this now as a quadratic equation equal to 0. So we're going to go n squared minus 6n plus 5 is equal to 0. Now we want to solve this, so we're going to factorise. So this goes to n. Now we need two numbers that add together to minus 6 and multiply together to positive 5. So that's going to be n minus 1 times n minus 5 is equal to 0. So that gives us solutions n is equal to 1 and n is equal to 5. So what that tells us, we got this quadratic. These values tell us where the quadratic cuts through the x-axis. So this now allows us to make a sketch of this quadratic. So we know we cross the x-axis when n is equal to 1 and n is equal to 5. So this quadratic is going to look like this, where this value is 1 and this value is 5. So we can now use the graph to solve the inequality. So what we want are values of n such that n squared minus 6n plus 5 is less than 0, so it's negative. So what we want then is the part of the graph below the x-axis. On the x-axis, the graph is equal to 0. Above the x-axis, the graph is greater than 0. Below, we are less than 0. So the part of the graph that we want is this bit. Now, we don't want the graph to be equal to 0. It's strictly less than 0. So we want x to be greater than 1 but less than 5, or n, sorry, we want n to be greater than 1 and less than 5. So the inequality we get from this is 1 is less than n is less than 5. So let's write that over here so we don't lose it. 1 is less than n is less than 5. So that is the solution to the quadratic inequality. Now we need to solve the linear inequality, which is going to be a lot easier. So we now want to solve 3n add 2 is less than or equal to 14. So 3n add 2 less than or equal to 14. Take away the 2 So we get 3n is less than or equal to 12, and then divide by 3, and we get n is less than or equal to 4. So that is telling us n is allowed to equal 4, and any whole number below it. So now we can get our solutions. The top inequality tells us n strictly has to be greater than 1 and less than 5. Now, the numbers then that tells us n is allowed to be is 2, 3, and 4. Now, all of those numbers are fine by the second inequality as well. There are no other values n can take, because then they wouldn't fit into the top inequality. So those are the answer. Okay guys, so there's the paper done. Really hope you found it useful. Please do give us a thumbs up, get subscribed, share with your friends. These things take a lot of time, so I want to help as many people as possible. I'm going to do paper 2 and paper 3, of course. When I've done them, they will be linked down below in the description. Take it easy guys, take care.